In this lesson we're going to look at the flow of charge around an electric circuit. So we've got a simple circuit here, and when we throw the switch, that's to say we close the switch, charges start to flow around this circuit, and they will flow from the high electrical potential, that's to say the positive terminal, to the low electrical potential, that's the negative terminal. So we can imagine charges flowing around this electric circuit, and by convention they flow in this direction. So what is the symbol for charge? Well, it's the capital letter Q, and its unit is the coulomb. So we can look at this diagram as coulombs of charge which are flowing around the circuit, and we can say that the flow of this charge around the circuit, that's to say how much charge flows per unit time, is called the current, which is given the symbol I because it used to be known as the current intensity. Okay, and we can say that I, the current, is equal to the amount of charge that flows per unit time and has a unit of coulombs per second, which is a compound unit which has been replaced by the amp. Okay, so you must always remember that amps are coulombs per second. So we can use a device which measures the flow of this charge around the circuit, that's to say how many coulombs are passing per second, and this is called an ammeter. And so we can say that if, for example, the ammeter reading were 3 amps, then that would mean that 3 coulombs of charge are passing through that ammeter every second. So if a coulomb of charge is represented by this red circle here, then 3 of these will pass through the ammeter every second. That's what 3 amps means. Now then, what we're aiming at in the next few lessons is to be able to calculate the energy transferred in an electric circuit. So we're going to need to know how much charge passes through a particular component in a given amount of time. So if we want to work out how much charge flows through this resistance in a given period of time, then we need to rearrange this expression here. Again, we can use a calculation triangle. Initial expression is I equals Q divided by T, so we're going to put the Q divided by T here, and then we slot the I in there. Okay, so what we're after in this particular case is the amount of charge that flows through the resistance. Well, that's going to be equal to, well, you cover up the Q here and you're left with I times T. Right, so supposing I wanted to know the amount of charge that flowed through this resistor, for example, in 1 minute. Okay, remember that time is measured in seconds, which is equal to 60 seconds. So the charge is equal to 3 times 60, which will be equal to 180 coulombs. Now in the next lesson we're going to look at this same simple electric circuit in the context of energy being transferred to and from the charge as it flows around the circuit.